All right, this problem has several steps to it. The information that you have across the top here is just all given information, and we're actually going to go back and use X, Y, and R to help us figure all of this out. Now you'll notice all of this first part is just in reference to angle A, and of course all of this is over here into reference B, or in reference to angle B. So first of all, let's just talk about angle A. All right, so let me just label here which angle we're working with. And I want you to determine X, Y, and R that pertains to angle A. Now, since you're given cosine, if you remember, cosine is equal to X over R. Now, I do have a negative value here, but if you remember, R can't ever be negative, so that means my negative sign is going to have to go with my X. So I'd have a negative 5 here. R is going to be the 13, which means I need to come up with Y. Now this happens to be one of those triples, but if you don't recognize that, you can use your Pythagorean theorem. The triple is that this is a 5, 12, 13. I just need to decide whether this needs to be positive 12 or negative 12, and that's going to be based on the quadrant that angle A is in. If you are in the second quadrant, any ordered pair that you have in the second quadrant, Y has to be a positive value, so this would be a positive 12. Okay, now I'm going to go through and I'm going to identify, of course I'm already given cosine, but I need to find sine and tangent both here. So sine of angle A, of course sine is Y over R, so I would have 12 over 13. And then same thing for tangent. Tangent is Y over X, so that would be 12 over negative 5. Okay, we need to do the same thing for angle B. Okay, so this time we'll use this information. So we've got to identify X and Y and R. Okay, so you're given sine of angle B, and sine is Y over R, so that means Y is going to be 3, R is going to be 5, so you need to come up with X. Again, this happens to be a triple, or you can use your Pythagorean theorem, but I've got to decide whether it needs to be positive 4 or negative 4, but angle B is in the first quadrant, so your X value in the first quadrant is always positive, so I would have a positive 4. And I need, again, sine, cosine, tangent. Of course, sine's already given to me, so let's find cosine of angle B. So again, cosine is X over R, so that would be 4 over 5. And then tangent of angle B is Y over X, so Y would be 3 and X would be 4. All right, now we'll actually be able to find what we're asked to find up here. So we'll find the cosine of A plus B first. Okay, so cosine of A plus B. Okay, so I'm just going to write down my identity just straight off the notes. And now you're going to pull the values that you have found here, here, or either one of those that was back at the top. Okay, first of all, we need cosine A. Now, cosine A was given to us. That was the negative 5 over 13. Okay, so I'll substitute in that value. Then I need cosine B, which is one of these here that we found, so that's 4/5. And then I need sine A, so sine A we found to be 12/13. And then sine B, of course sine B was given to us, so back at the top you can see that that is 3/5. All right, order of operations you need to do the multiplication before you do the subtraction. So of course, just multiplying the fractions here, we'll have negative 20 over 65, yes, minus, and then multiplying these two fractions, we would have 36 over 65. Okay, you already have your common denominator there, so you don't even have to worry about finding that. So just subtract your numerators. So we'll get negative 56 over 65. So there is your answer for that part. Okay, next. The other item that you were asked to find was tangent of A minus B. Okay, so I'll just write down the identity again, just straight off the notes. Okay, so again, just replacing the values from what we had found. So tangent A is negative 12/5 minus tangent B, which is 3/4, divided by 1 plus, and then you'd have the negative 12/5 times the 3/4. Now you can use a calculator to help you out as much as you want to here. Doing a little bit of this by hand though, the first thing you need to do is multiply the two fractions that you have here. That would end up being minus when you do the multiplication. So we'll have 36 over 20, and then 36 over 20 will reduce to be 9 over 5. Okay, so we have a complex fraction. So again, you can use a calculator, but you can also go through and multiply each of these terms by the common denominator, which would be 20. So like I said, you're multiplying each term on the top times 20, and then each term on the bottom times 20. All right, so multiplying this times 20, I'm going to get negative 48. Multiplying here by 20, I'm going to get 15. Of course, 1 times 20 is 20. And multiplying this by 20, I would get 36. So I end up with, my numerator is negative 63. Of course, on the bottom, you get negative 16. So, of course, that ends up being positive. So 63 over 16 is your final answer for that. So once you find all of those values, you know, sine, cosine, and tangent for angle A, and sine, cosine, tangent for angle B, you actually could be asked to find any of the 6 identities using the sum or difference of any of those identities.